All right. Um, cool. We're streaming. So this is me. I'm actually streaming one camera to the other computer. Because yeah, this is actually better than the USB camera I have, believe it or not, quality wise. Okay, so deal here is that we have a problem as usual. So I need to figure out how to make this a second display that is virtual. Duplicate or extend to connect displays, change the resolution. Windows, there's some way to do this. I can't remember what it is, so we're probably gonna have to Google it. Um, but Windows has a way to add like an extra VGA adapter or something. Older displays, select a tech to connect them. No. To a wireless display. No. Graphics settings. Why is hardware accelerated GPU scheduling not turned on? That seems like, based on the description, something you would want on by default. Okay, setting up multiple monitors. Okay. There should be some kind of virtual VGA. And the reason we're doing this is because Discord freezes, and actually, I think Chrome itself freezes windows that um, aren't active on the top pane. Do do do. Okay. I don't want to download anything. Uh, Try to connect anyways on VGA. Oh yeah, this option is probably long dead. That probably died with like XP. Um, when is this? 2014? Try to connect anyway on VGA. Click apply. Extended. Second screen plugged into your computer. Okay, I don't think we really need to deal with this right now. I will make the USB some other day, because this is just getting a little ridiculous. All right, this should be our video. Um, oh, but yeah, you can't see. Can you see me? Oh yeah, you can. Okay. Well, great. Okay, then we don't have to do that anyways. Um, so try to take the part of the green color out of the overlay here and see if I can be transparent. So always trying to be transparent. So that's why we're doing these videos. So in the spirit of transparency, let's get to it. I want to document the whole process. So, okay, where'd we leave off? Okay, I think I got down a rat hole. I got down a rat hole. I cut off the video. I made another video. I got down another rat hole. Okay, we're back. We're just gonna get down to business. Okay. So first thing is the introduction. This maps to the titling of the past video and this video. So we're going to start with, we're going to do a set of volumes for this series. Um, and it's a big project we got planned here. So we're going to see a set of volumes for this series. Volume 0 will sort of set the stage for us, give us our kind of operating parameters. This is where we're going to do our planning, essentially. And then volume 1 will be Alice's Alice's Adventures in Wonderland, where we're actually going to rewrite Alice in Wonderland, and we're going to then change it into something that's applicable to our case, which is architecting this software architect of Alice, right? And how we're going to build her and all the stuff that's going to go into it. So, okay. And then obviously the tutorial series is to teach how to do the same thing. So these are engineering logs on how we're going about the process of building the tutorial series. So we've got a few people involved already who, we're going to loop into different parts of this. And then, us in the community who are active and watch the videos on YouTube. Uh, and, we show up in the weekly syncs. um, we've been doing a lot of the machine learning stuff that's been building up to this, right? And so basically, I think um, we've got the thing that's going to let us tie together the operations and the CLI and the ML, and the data flows. I think it came together. Is the long short of it. Now we're going to go into the long of it. So. Yeah, it all came together. Figured out shared config, figured out unification with Python type system, figured out what was the other one? Shared config. Oh, system local resource management, and yeah, there's just there's a lot of good things that flow from figuring those out. Um, and also manifest overall architecture involving the distributed, a possible optimal distributed compute situation. It's going to be based on a project called KCP, which is going to decouple a Kubernetes API server from the cluster interface. And so basically that's going to allow us to swap out and create a bunch of custom CRDs under there. And then we're going to do the first thing of that today is that we're actually going to then write some proxies in there so that we can invoke these Kubernetes APIs instead of we'll basically run a little service within KCP, which is basically my understanding is they're all basically CRDs. And so some kind of background job that we'll spin up on start that's going to take messages from that are we can interpret as being from like the Web3 space, and we're going to go and let's see, can you see me better for here? Okay, maybe I took too much green out of the background. So we're gonna basically grab that DID spec. That's what we're gonna be doing today. We're gonna try to understand that. We're gonna try to understand how that relates to the web relay nodes, and we're gonna try to understand where personal data stores are at. I don't think we're not actually going to touch that. We're not going to touch personal data stores for now. That probably will be when we get to identity aware contexts. These are contexts running within a data flow. So that's when we'll want to look at, um, that's going to be when we want to look more at personal data stores, I believe. Um, but in the meantime, and tonight's activity, the main event is what the hell's going on with these TID specs. And a few of you who have heard me lately, I've basically been champion this thing that I know very little about here. So I read a little bit of the spec, and it seems perfect based on what I skimmed. But granted, I spent about 2 minutes reading this thing. Most of it was looking at a flowchart. So I'm really hoping that that was correct assumptions. And what I think is the assumptions I gleaned from skimming it were basically that is we're going to build a giant linked list. Some of this metadata is, or basically some of this stuff goes on chain, and that's like I'm putting something in the blockchain. Now, we don't really want to put a lot of stuff in the blockchain. So this kind of follows with the rest of what we've been talking about with Alice, and if you're following the discussions thread, which is that, we're going to sort of encode software like it's DNA, and, different little organisms have different jobs, right? And their job is encoded in their DNA. And so, every time you got something to do, you're basically going to spit out this little piece of DNA that's the Alice for that job. Um, and uh, so let's see, let's roll that back. Um, so when you do that, basically what we can do is we can encode a manifest, and a manifest is basically, so you got to go check the thread. That one requires full explanation. There's full write-up with the demo and an example. So this is gonna be a critical first part here. Essentially, it's we're gonna write these um, JSON schemas paired with ADRs, and they're going to be used to validate. Um, they're going to be used to validate the effectively the schema. The ADR defines the contract that accepting this as so think of it like think of everything like we're building a big distributed system, right? And we're basically going to have this sort of like synoc um, awk flow. I got to go get my t-shirt. Um, and so basically, let's just not assume that something gets done, if it just because the job got accepted, is what I'm trying to say. Basically, here's the job, and then, sometime later, I'm finished with the job, and then, are you finished with the job? Something like that. Um, but that'll all be facilitated by adding more links to the chain. So basically, what we've got is we've got these directed acyclic graphs which form our data flows, right? And when one of the changes that we're going to make is to instantiate um, the operations via passing them in as inputs to an operation. And that way we are able to support this shared config stuff because we can pass by reference to the instantiated objects in a particular sequence. We can support the sort of secret unlocking from various sources because we can chain together arbitrarily complex sequences of operations to do that. Um, and yeah, it does. Oh, that was another big thing. Yeah, but that wasn't an issue particularly. So uh, when we do this, basically we're gonna have this idea of cached data flows, right? And so this is like I'm gonna save a data flow, I'm gonna load a data flow. We've been talking about this forever, right? We just got the model stuff working. Great job, everybody who was involved in that. Um, but yeah, so this is the more generic form, right? And we were playing with this. We were like, what do we do? What do we do? What do we do? We couldn't figure it out. I mean, we've been playing with this for years. And so um, I I believe the trick is in sort of, and we've talked about unification of the command line interfaces and the operations and the classes themselves and the data flows, and then the Python type system, right? Like all this stuff has to come together, or else it's just we've got this kind of clunky mess right now, right? We know there's something going on, but it's a little bit of a mess, right? APIs aren't consistent. That was part of the guiding principles. We should have consistent APIs across all the interfaces, and now we've kind of we've grown and we're in need of cleanup. And I think so basically what I'm saying here is that I've been doing some cleanup, conceptual cleanup, and now it's time to go plan out how that hits the code, um, and what new features are involved there, and what that how the future roadmap impacts that cleanup. So we're going to basically refactor as we go, and we're going to map our refactoring activities to our feature development activities to our bug fix activities, and we're going to take those, we're going to map them into these chapters, which is this chapters of this tutorial series that we're going to write, and um, yeah, we're gonna have a hell of a great time, I hope. So okay, so basically, and I think I rolled on a train of thought there. But I was talking about the cache data flows and it all being the same thing. So what we need to do, I believe, is we're going to test this out. We're going to test all this stuff out. Is we need to have a concept of like a top level flow. Um, and that's not necessarily to say it's the top level flow. And we're also going to rely heavily on the overlay concept as well for a lot of this stuff. So um, so if you think about the overlays, right? The overlays are effectively, and I think there's what the one of the examples covers the overlays. I believe it's the one where we take the automating classification data and the should I data, and then we run them together in the same data flow via the HTTP service. Okay, so what does this represent? Um, this represents the upstream tracking model, right? So what is this overlay? Well, the overlay is the diff, right? The overlay is the upstream is basically um, the upstream is basically. I guess I should just make myself big because I'm just talking. Maybe I should talk to Alice. Okay. Oh, this is a stream. Well, great. All right. Well, you guys, you'll use these on the recording. So, all right. So where are we? And this is why we're also doing this as videos because I'm gonna, we're gonna have Alice. We're gonna go through YouTube's transcription, or we're gonna have Alice do this transcription, and we're turning this all into notes. And we're basically, I just want to have data on everything, everything, all the time. And that's part of what's going to happen here. Okay, so we were talking about importing and exporting data, um, and the needing to have the top level context. So basically, when we run, when we run and when we run, okay, yeah. All right, so you'll notice that this maps onto my areas of focus because, uh, probably gonna author a fair amount of this tutorial series. I would hope other people, want to author it with me here. But this is basically this is what I'm seeing as the places that are really need to be nailed down to build Alice, and so these are the things that I am therefore involved in. And so yeah, that's why I wrote them here. If you see other areas that are critical in the building of you should, propose, add an edit to this document, and this will be something that'll be available as a pull request to comment on. And you can say, hey, we really need to look at this area, right? And so this is, where we blank subfield of computers is where we need to look to understand what's the state of art happening in this area. How does it apply to what our AI's understanding of software engineering is. So please, be on the lookout for that. Okay, God, there's so much stuff, and part of this is about how to organize it. So just trying to get everything out there. Okay, so the importing, this is just that train of thought is obviously way too far gone. Um, uh, we'll cover it all. I think what are we gonna get to? Let's just do tonight's thing, and then we'll kind of go piece by piece. I'm gonna write some stuff up more, and then I'll give more coherent and organized thought versions of what I've been blabbing on about, but you can read the full. Basically, I'm writing down all of my thoughts related to this, and it's all here. And I am asking everybody to please write down their thoughts as well, so we can all go build this thing because this is going to be ridiculous. So yeah, there's going to be a lot of work involved. This is like a years long effort across n amount of people who want to be involved. So just putting it all out there so we can all just like figure out who needs to do what, right? I'm sure we're all thinking about this stuff, so I figured it might be nice to have some place to think together. That's really what this is about, actually, and that's all in here too. Is to come together to think together. Um, okay. Um, okay. So, all right. Well, let's just go look at the Web3 stuff. I hope this is running. Okay. Oh, yeah. It's just a little bit behind. Great. Okay. So, all right. So from the discussion thread, um, from the discussion thread. Okay. No. Da, da. Oh yeah. And so why do we want to do this? Well, basically, um, things are going this way. I don't think anybody would argue that, right? We know there's going to be blockchain, Web3, whatever. It's sort of a given. We know that there is some sort of next step in what's a commodity as far as compute is concerned, right? So, um, and I think part of what's going to happen here is that this commodity is this AI. You know, it's 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 some kind of like data AI uh, operation hybrid. Um, I think I have notes on it somewhere, but and these are basically like clumps of models. Um, and these clumps of models, just like that DNA that sort of will create for these little Alices that live on chain, these are like entities in a way, because it functions like DNA. So it's like software DNA. Software is DNA because basically we won't need to write any code. I don't think because I think Alice will just be able to write all the code. Um, uh, because I mean, look at like Copilot and stuff, right? So I think that the main thing here that we're trying to do is we're trying to map intent to code, and once you can map intent to code, she can go learn fast, is the guess. Um, and so that's what we're trying to do here. And then obviously part of this is going on these overlays, right? So we're going to overlay all these strategic plans on top of these things. And right, part of what's going on with machine learning is that sometimes we're not so sure how things get done, right? And sometimes we're not so sure if we remember to add our extra input validation on the output of our model to check for these, corner cases if we're looking at, potentially malicious input data, right? Um, uh, it would be really nice, effectively, to have static analysis across all of, every language to map intent to code in that language. And basically, Alice is going to need to do that. And so once you have that, the question really becomes, well, okay, so where do you go from there, right? Well, how do you decide what to do next? Well, how do any of us decide what to do next? And we're going to follow this sort of mental model of human thought to figure out, how should our robot think, right? And it needs to think in ways that we can trust and that we can understand, and we need this sort of shared language for communication. And the proposal is effectively uh, that we this shared language is effectively this like it's like this manifest, and the manifest allows for arbitrarily deep levels of nested manifests, which is sort of like your plugin instantiation. Um, and all of these, subsequent, and it is very similar to like the Kubernetes API server CRD concept, right, where you're defining these different API types and stuff, right, or like an Open API v3 spec or something, right. So basically, just give me all the metadata, give me the function prototypes, right, and if you've got the function prototypes about everything, you can sort of just and you understand intent mapped to the data involved, you can sort of just start, building you can build all sorts of stuff, right? That's what we're gonna do. And so you can then map that to abstract concepts by doing essentially like this, I believe a sort of 2 by 2 matrix conversion, uh, like in um, basically like an image to, you can think of it like doing doing a GAN. If you're doing like an image GAN, and you want to take one picture and make it in the style of another picture, right? Like you're painting as another painter, right? Or like in this case, I believe what it's going to be like is like you're seeing through somebody else's eyes, right? Effectively, because you can apply all these sort of like views, and these views are the views on the data, right? And um, so the views on the data are effectively these strategic plans, which are effectively just like output operations, which we're going to overlay on top of data flows. And this is coincidentally, and probably not so coincidentally, but exactly what we were doing for this data flows is class pull requests that some have noticed is stale. So we're going to get back to that right away. And it also ties into this concept of caching, where we're going to, um, God damn it, I'm on another rabbit hole. This is why also Alice in Wonderland. Okay, so basically, we're going to build all these models. The models are going to help us understand the data in a language that we understand, right? And so, therefore, a fundamental piece of this whole data AI sort of compute in that that's kind of wrapped up in the manifest thing with the spec, um, is this ability to sort of transform one view of something into another view of something, right? Like anything. You can sort of take A and get B, as long as you give me some context around, what my parameters are, you know. Um, you know, take this picture of a fish and make it look like Van Gogh painted it, right? But like, take the concept of um, democracy and make it look like Van Gogh painted it, right? Like that's the type of stuff we're talking about here. Um, and doing that like in sort of like this multi-dimensional space by training all these models against each other, and that way you can say, like mix the concept of democracy and Picasso or whatever, right, to create like code. um, it sounds ridiculous, but I think it's possible. I think it's 100% it's possible. And so, because it's basically it's everything is basically like a encoder. There's a lot of it is basically like an encoder decoder translate, like a language translation model. Um, as far as I can see, but we're going to find out. Um, and so essentially, the point of this is that since you can see anything through anybody's eyes, you can get together as these organizationally formed groups of people where all of the agents sort of uh, vote for these strategic plans to be in place across all of the data flows. And this is how you can create this kind of like system for IoT devices and all of this stuff, to where you can go out in the world and you can see it, and they have like this attestation information, and you can verify whether they're running these strategic plans, or whether they've accepted input from a strategic decision maker or strategic planner, which is something that you trust, right? Or that you are okay with, right? Like, so you could be at the grocery store and you could wave your phone over a set of items, right? And it could do the image detection and the barcode reading just by going over, and it could look up the company and information, and it could then map that to what you care about, right? So maybe I'm like, you know, I care about if this, all I care about is this food keto, right? And it will like look up calorie counts on the fly, right? Like that is my organization that I'm a part of. Um, the keto organization, and so, and then you could also be like, um, uh, you know, is it um you see what I'm saying? Like this is I picked the keto one because it's got multiple steps. You've got to look up the calories and stuff. You got to look up what food and then what calories, right? So basically, you want assurance that uh, eh, okay, all right, we're just gonna look at the DID stuff, and I'm gonna write the plans because there's just too much. It's just too much to talk about. It's too much. All right. Okay. So how is this structured? So basically, this is the mission. Why? If you can do this, I can see as somebody else, I can see as a whole organization, and I can understand what the whole organization thinks is freedom and privacy preserving, and then I can basically like only uh, um, like I can only shop at stores who I know are supporting these strategic plans or something. You can get arbitrarily complex, and that's why the first thing that we're doing is we're going to look at this Web3 stuff because we want to build from a solid foundation here. And if we can just put all this data, I don't know what on-chain means, but on-chain or something like that, like I don't know, maybe that's the way we're supposed to do it, but we're not going to do that. I mean, we're not going to put all the data on there. That's what the manifests are for, and the little tiny, versions of Alice in these tiny DNA strands so that we can put the smallest amount of information on chain as possible. Um, Great. Okay, let's get going. So let's go look at the spec. Okay. Um, this thing is full of stuff. I'm gonna dump it to Markdown documents. Okay, so DID. Oh, this is in here like a million times. I've been writing this for like a while now. I've been writing. Okay, so this is the most relevant comment. Can you see? Yes, you can. Great. Sorry about the 4K, but I gotta have the 4K to figure this out. Um, okay, yeah. We're gonna have to see a lot of things at the same time. Um, okay, so basically, I think DWN was distributed web node, DID personal data store, and like I said, we're not going to touch the personal data store thing right now, just because you know I don't think it's worth. I don't think it's worth getting into that. Um, I, at this point, I think from what I understood, it's not. I don't know if they have like enough examples that we could just jump into it yet, and I think it's more relevant to the authentication and authorization problems that we'll run into down the line. We're just going to ignore those for now, as one does. And the way that we ignore those is not by writing insecure code. It's by writing secure code, just writing not that much of it because it takes a long time to write. So write one secure complete implementation and then don't write a million little examples, and then you get where we're at. So that's why all of my SQL source has the TLS on and everything. So okay, so basically, yeah, we just don't we're not going to do any examples that are going to be auth related, and then we're not going to need to deal with that so much, at least in a complicated sense. Um, okay, so what does this say? So I like to. This is just. I'm just gonna give full thought process for the sake of the recording. So I like to hit the middle mouse click and open every link I find, and this is why there's so many links on here. Basically, I'll skim something and then I'll go through and I'll go, boom, I need that, boom, I need that, and boom, I need that. And then I'll go through here, then and I'll click, I'll give each one a quick control tab, kind of see which ones I do need and don't need, close the ones I don't need, and then, I go back to the duplicate, right? Okay, here we are. Now we're good. Now we know what we need. And sort of like a binary search for information as soon as you open all the links, right? Okay, so this is the spec, and here's the quick summary of the spec, and yet another reason listed why that's to pick the name Alice is because it's already in a million people's docs. So yeah, basically I saw this picture and I was like, this looks great. This looks like the problems that like Gun is trying to solve and things like that. And we, I may have tried to rope a few people into a project called Chill Chat a while ago. You'll notice things like very very similar. Um, so basically asymmetric keys and like sign this, I sign this, you sign that. Sort of like uh, here's my data, pass it along. I have to sign it for everybody. That's kind of where it gets annoying. And then you have to like, grant claims to other people to do things with your data. What do you trust them to do? Once again, same thing as loops back into the operations discussion and executing all of this. So, all right, I should probably read this instead of just talk. Okay. And what is this? Where are we? Is this decentralized web node? Okay, so this is interesting. Maybe we should read this first because I think this seems much more helpful. No offense to anybody who wrote the DID spec, but I didn't really understand what was going on here. This seems to give more of a concrete example. So, decentralized web node is a draft specification under the development of the Decentralized Identity Foundation, incorporates requirements and learnings from related work and many active industry players into a shared specification that meets the collective needs of the community. The specification will be updated to incorporate feedback from IDF members, or not DIF members and wider community, with a reference implementation being developed within DIF that, okay, perfect reference implementation. I love to hear that. At that point, you can basically, oh, this guy's great. This guy knows what he's doing. Um, I've been following him on Twitter. That's how I found out about this stuff, as well as um, I saw Kelsey start taking it more seriously, and I saw Angie Jones start taking it more seriously. And then I saw this guy Daniel, and I saw what is her name? Zelinka, Brooklyn Zelinka, and she's very smart. I could tell she seemed very smart, so I was like, these are some people I should go listen to. And sure enough, they were right. And so they're leading some really cool stuff here. And okay, so this is cool. What's this? Is this the same thing? It's the same thing. Okay, let's go. Basically, now I click until I find code. Then I run the code. You can see why I'm thinking that the logical step here is to build an AI that does the same thing. Implementation is JavaScript. Fantastic. Basically, if we can skip reading this spec and just running something immediately, then we can basically look at the spec for errors. And if we don't run into the errors, then great. If we do, then we'd consult the spec. All right, what's this? So look at this, main, MJS, never heard of MJS. Interesting. Feature IPFS, okay. IPFS. Encrypt. So basically their file system is IPFS. Okay, so does that mean that these DSD, so I'm also trying to understand where do these DIDs live? Like that's why I'm also interested in the web node is because I found this thing that like implies that you can sort of claim a namespace in a distributed fashion by putting it under a .well-known directory, which is apparently some spec that's been around from like the 90s or something. I don't know. It's been around for a while, but I was surprised. I was surprised nobody has. I'm surprised I haven't heard more people using this. This seems like a really great way to anchor a root of trust on a domain for an alternate protocol. Um, I'm like very pleased. Um, okay, so flatten sign, flatten encrypt, messages compose, validated, validate. Um, let's see. Are we getting any of this? Are we not? Oh no, I hope that we're getting this. I just spent a lot of time talking. I hope we're getting this. Oh man, did it not go? Oh man, it says we're live. Well, at least nobody is seeing this sadness, but I don't understand. Is this real? I feel very disheartened. I hope it's, man, I hope I didn't spend a lot of time. Would have looked at the DIDs. Come on, come on. Please be recording this. Okay. Is that me? Am I here? Is it live? Oh, God, this stuff. I am really bad at this stuff. Oh, yes, there's me. I am live. Oh, look, there's one person watching. Thank God. I hope that works out. Um, I know somebody will watch. Um, um, okay, where were we? All right, let's get back here. Okay, I can close this. Okay, cool. All right, fantastic. Well, oh yeah, I don't seem to be. Where's my mouse? Is invisible. My mouse is invisible. Okay, great. How are we gonna do this? Why is my mouse invisible? Look, you can see it on the OBS screen. This is ridiculous. Um, okay. Okay, I got it back. Oh, there I am. Okay, let's go figure out the DID spec. Okay, so we were looking at this. Messages. All right, let's go to the beginning of this. Identity hub. Oh, this is clean. Very nice. Very nice. Very nice, Daniel. All right. Um, Identity Hub instance has its own DID. Okay, so what I'm thinking here is that these DIDs, yeah, like I said, linkless. Okay, I already said that. Compose message, validator dot validate. God, I love it when the validators validate. That is just the way to go. I really wouldn't have it any other way. Um, Dagify message. What is that? I want to know about that. What is that? What is Dagify? Dagified. CID. What's a CID? See, these are things that I want Alice to take notes on. I'm sick of taking notes. What's a DID? Question mark. And then we can figure out the goal. And then this is part of why we're doing this series of videos. Because when we say, hello, moth, when we say, what's a DID? Um, it would be nice if Alice could just chime in on the side and say, "Oh, by the way, oh, this is what I don't know, we're figuring out. This is what a CID is, right? That would be great. Instead, we're gonna have to look at this for like 30 more minutes, which is fine, which is fine, which is fine. It's fun, but it would be nice to not have to do this at all. So, um, you know, that's kind of the goal here. Um, I figured if we're sort of anybody working on this project is sort of like working to build a thing that will put them out of a job if you're a software engineer. So basically, you always have job security because uh, if you if you if you basically if you do finish the job, then great. Like then you should done, right? If we finish this, it's gonna be able to do anything. So as long as you're working on this, basically, I think it's a good way to have a job. I think so. I think so. Um, in the event that you lose, you win. So in the event that you win, you win. So it seems like a good plan. Um, so message descriptor CID. I have no idea what that means. Is it a IPFS? It is a IPFS construct, and we know that because IPFS.add is going to return something that is specific to IPFS, probably some kind of internal identifier like some kind of UID. Um, so I'm guessing that the CID is so this is probably where in IPFS the DID lives. So this is probably like I was saying, is it? Yeah, I think this is prop data. I'm not even reading this. Okay, read it. Um, if I could just read one line at a time, I might figure out what things mean. Okay. Let IPFS equals options tagify promises data in message. If not, data description. So what is the rest of this? Pick, merge. Where the hell does this get used? God, GitHub, thank you. Oh, this is how we got here. That's right. I was like, I want to know more about that. Um, mm, or is this not? Where is this? No, this is interface. Where's the entry point for this? That's what we should be asking. This was a bad idea of me. I should have asked that. This would be the correct thing to do. Would say where is the entry point for this? Who's this? I've seen him around. Yeah. You guys can see this, right? Okay. It's probably some kind of workflows, render specs. Aha, and this is why we love CI, because here's the answers, all of them, right here at our fingertips. Install and build. Require sync up, no watch true. I think I'm gonna like whatever is going on here, based on what I've seen so far. What is that? There's some noise. All right. A little bit of hippity hoppity clickety clackety. All right. Spec up. Require spec up. Okay, so what's this library? Spec up. So this is, I want, can we use, no, I don't have that. We should get that and we should test it. Spec up. No, go to NPM. Urban Dictionary. Why would you take us to Urban Dictionary? One time, watch this. Look at this. Look at this. Look what happens. Look what happens. Just, just, just imagine, imagine, imagine you really, 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 really want to know more about this file format. You're desperate to know. You type in ELF. Really excited to see a nice design created of the whole layout. Wait a minute, maybe you type capital ELF. Nope. Well, I was presented with Will Ferrell in an elf costume, and I was shocked, mind you, one time. All right. Great. Oh, great. We're gonna have to pick that out of the training data. Okay, wait. So these guys authored this too. So let's go check it out. These people, these wonderful people. These people are great. Um, Technical specification development. Oh, I love this already. Oh my God, this looks fucking great. Oh my God, this is fantastic. Okay, this is like, God, this is, okay, this is beautiful, is what this is. So basically, okay, I like this. I like this a lot. Um, but, but I think Claire's project is going to take this even further. Woohoo! Woohoo, Claire and Michael. Yay! That's going to be great. Um, I think we're going to be able to merge that with this even. Should we merge that with this? We should merge that with this. We should merge that with this with eventually the system context. Yeah. Yes, this is effectively show me the notes. So there's a demo in there that's basically like, hey, rewrite these notes. Basically, the goal is take stream of audio with unrelated topics and create cohesive thoughts out of them. It's the task. Um, so obviously, we're going to need to build an AI to figure this one out. Um, so, all right. And I mean, you can basically take that and scale that up to every single thing that you see on the internet, right? Makes sense of it all. So, or in this DID web. Okay, so basically what they have is they have something kind of like our console test situation where they've got their test cases and their docs and they're linked. And so when you do spec up no watch true, so there's no watch, um, not documented. Oh, this is for the different file. Hey, what's up? Oh, yeah, I'm sorry, dude.